We live in a world in which the new most valuable asset is data. For example, when you think about ChatGPT or those large language models that we use every day now, they use a huge amount of data to train those models that now we use so often in our daily lives. But these are real data. I mean, for example, OpenAI use real data to train their model, and they use the whole internet to do it. And those were all, as I said, real data. But what does it mean to be real data? It means that they were produced by humans. So we were the source of those data. But there are some restrictions to this data in certain cases. For example, think about medical research or financial data in general. They are restricted. There is a privacy concern in those data, in accessing those data. But so what is the problem? The problem is that those data are not easily available to everybody. And now, with the rise of generative AI and artificial intelligence in general, we need this data to train models and to advance these state-of-the-art models. As I said, the problem is that those data are not available. So what can we do? Well, the solution could be, one of the solutions could be creating synthetic data instead of real data. So what does it mean? It means that we take the real data that we have, so say, for example, data in the medical field, so report for patients in a hospital, and we want to use this data, but instead of using the real data, so the real data with the name of the patients and all their informations, we are going to use similar data, very similar statistically, so with the same, for example, mean or variance for some of the columns in this kind of tabular data, but we're gonna generate this synthetically. So we're gonna use, in this case, I'm gonna be a little technical, a machine learning model to train this model and then generate new synthetic data. These data are gonna be completely free to access because they're not gonna contain the data, the actual sensitive data of the patient or of whatever your goal is. So my project is about generating this new synthetic data, but with new techniques that actually can make them better and more qualitative to use in, for example, training those large language models that we were talking about before. So how do we do that? First of all, we have to take a step back and actually see how these synthetic data are generated in general. So until this moment, the most used model to create this synthetic data was called, I'm going to be a little technical now, called the multi-layer perceptrons. And those are, basically you can think about, when I say the word model, you can think about a machine in which you input the data and you get the synthetic data. We don't actually know what is, we know some of the technical part about what is inside that machine, but for the sake of simplicity, just think about, you input the data, there is this machine that does something to this kind of data, and then output the synthetic data that we can use and without any restriction. So, as I said, so far we have been using the multi-layer perceptron framework. That is a classic version of a neural network. So a neural network, you can think about it as, it's called neural network because of the similarity with the human brain. So the connection in the human brain, the neurons and the axons and everything is not exactly the same, but the name helps us understand what is in general. So my idea, my project in particular, explore a way to generate this synthetic data without using the multi-layer perceptron, but by using a new framework that has been introduced a few years ago by some researcher at MIT. And this framework is based on a known mathematical theorem in representational theory that is called the Kolmogorov-Arnold theorem, and the network is called the Kolmogorov-Arnold network. So instead of using multi-layer perceptron, I'm going to use Kolmogorov-Arnold networks. So I know those are a lot of words and a lot of technical words. Kolmogorov-Arnold is basically the name of two mathematicians. But what is important to understand is that the promise of this Kolmogorov-Arnold network is to create, to better represent. That's what I wanted to try to prove. That not to prove in math you don't say prove. This is not a math proof, so I'm not gonna say proof. But to make the idea clear is that I wanted to show that this Kolmogorov-Arnold network could represent the synthetic data better. It could create better synthetic data instead of the usual multilayer perceptron that we used to use so far. So the promise of this Kolmogorov-Arnold is exactly that it could capture better the complex relationship on the real data to create better synthetic data. And so how did I do it? I created 6 versions of existing generators. So generators are these models. And I used 2 that were already available. So these 2 models use, as I said, those multi-layer perceptrons, and I substituted those multi-layer perceptrons in those models with the Kolmogorov-Arnold networks. So my job was basically to replace this multi-layer perceptron and input the new Kolmogorov-Arnold network. So you can think about it as the brain of the model. So I'm basically substituting the old brain with a new brain and see if this function better or worse. Who knows? So I created these 6 versions of those existing models with different tweaks in the parameters of the Kolmogorov-Arnold network. I'm not going to say all the details, but the important thing is that those are 6 different models. And then I evaluated the performance of these models with specific metrics. So I'm going to tell you the 3 metrics that I used. And so the first one was statistical fidelity. And so basically, this metric wants to answer the question, does the synthetic data look like the real one? And then the second metric was the machine learning utility. So can models trained on synthetic data perform well? And then the third one is the efficiency. So how fast and light are these models? So how fast can they create the synthetic data? Because that's another problem that could arise in a real world scenario. Let's think about you want to create you want to use these models for a production machine, for something in the real world. And so in that case, you actually care about efficiency. If it in other domain, like for example, if you want to use this data to train another model or to, access reports that are otherwise sensitive, and so you couldn't access it to train your models, then in that case, you don't really care about how fast these models are because you only need them to create those data that then you're going to use for other purposes. So those were the three performance metrics that I used. And what did I find? I found out that those Kolmogorov-Arnold network-based models are usually generated more realistic data than the old ones. So the synthetic data generated by these new models that I introduced were more realistic, more close to the real data than the data generated by the old models. So that's a pretty good result. Almost all the 6 models generated synthetic data that were better than the old ones. But what's the trade-off? The trade-off is that, of course, these are seems to be more accurate in the generation of the synthetic data on the 3 metrics that I use, because of course there are limitations also in the use of the metrics. You could argue that you could use other metrics to evaluate the actual usefulness of this synthetic data. But for these 3 specific metrics, the synthetic data created by the Kolmogorov-Arnold networks-based models were better. But what's the trade-off? The trade-off is that the Kolmogorov-Arnold network in general much more heavy than the other models, than the multi-layer perceptrons. And that's due to the fact that of course, the better representational, the better way of representing the data comes from the fact that those models use more parameters and they are heavier in general. I'm not going into details, but in general, heavier. So those models were better in creating accurate data, but much less efficient than the other ones. So they use much more memory and they were much slower to generate this data. So that's a trade-off, as I said. If the goal of generating this synthetic data is to actually use these models in a real-world scenario that need actually to generate to generate the data in a fast way. So you need the data in a small period of time. That's not. I believe that the Kolmogorov-Arnold network that I use are not the best ones. But if your only goal is to actually generate the best synthetic data possible, then I believe that these Kolmogorov-Arnold network-based models could actually be useful in a real-world scenario. For example, as I said, let's say that we want to access data that are scarce or sensitive. So, for example, let's go back to the example of medical data. Let's say we have 500 rows of data, and to train a model, this is not a lot. As I said, ChatGPT was trained on the whole internet basically, and 500 rows of data is nothing. So we want to expand this data by using this kind of models that then will generate synthetic data, and then we will have a lot more data that resemble the statistical property of the real data, but actually are synthetic, and so you can use it without any privacy concern, for example. And in that case, my model the model that I propose will be better to use than another model that is already in production. So, to conclude the podcast, we can say that the finding of this research was that there is a trade-off between the new Kolmogorov-Arnold network-based models and efficiency, but the Kolmogorov-Arnold network-based models actually generated more realistic data than the old ones, and so there could be a useful way to use this new model. And these models actually are publicly available now. So I created an open source Python package that can be installed by everybody, and so these models are actually publicly available now, and so they can be used by everybody. And so now I want to conclude with a question. So we're talking about real and synthetic data, but so what if synthetic data becomes so good and so close to the real data that we don't need real data anymore? What would be the consequence of creating real data if we don't need anymore? So what would be the usefulness of generating real data if we don't need them? So, but now I want to finish the podcast with a question for you. So, if synthetic data becomes as good as real data, what's the need of real data in the first place? So what would be, if we say that we are the real data, what would be the use of us? Why would be humans still useful in this scenario? Hopefully, we will figure out that it's not the case, but who knows?